Hope the screen is visible. Before I have to start Fourier series, I will introduce few basic concept. What basic concept is already I explained in a Laplace transform. If you remember, always remember that is a integration by parts, u into v into dx. We have to perform integration by parts. So u as it is, take the integration of v, we can write as a first integration of v, then minus sign, take the derivative of this u, so you will get first derivative of u, that is u dash. Then again you have to take the integration of this v1, so you will get v2 plus 50. Then take the derivative of this u dash. Don't consider this negative sign, only consider this part. So derivative of u dash will becomes u double dash, and integration of v2 is v3, then minus u triple dash to so on. So this method we have to use here in Fourier series, that is integration by parts. Basically this integration by parts is based on this word. You should remember this part: logarithmic, inverse function, algebraic functions, trigonometric functions, and exponential functions. According to this alphabets, you have to convey. Suppose if the functions of a pair like algebraic and trigonometric is given in a questions, so you have to use A comes first, T comes later. So we can say that A is our U and T is my V. So this is the concept. Maximum in your syllabus, there is a exponential into algebra is there, trigonometric into algebra is there, and algebraic into trigonometric into exponential is there. No logarithmic function will be there, no inverse function will be there. Only this, you have to deal with these three functions, or this three type of functions you have to deal: algebraic, trigonometric, and exponential. So you should remember these three functions. Which functions come first? Algebraic, trigonometric, and exponential. One more thing, that is algebraic functions and exponential functions. Both the functions are continuously differentiable and continuously, or continuity functions. Why continuity? I'm saying that if I'm going to calculate the derivative of sine x n number of times, I can calculate. It will never turns to a zero. But when I calculate the derivative of x raised to n at some time, or suppose if I have to calculate only x, then the second derivative of x will be zero directly, because the first derivative of x will becomes 1 and the second derivative of x will be 0. So you should remember these things, that is when exponential and algebraic functions are present, there is a one special formula. Definitely when the problem will come, I will revise the concept, or the formula of exponential into trigonometric. But for algebraic and trigonometric and algebraic and exponential, if the functions will come like this, you have to use this formula. Please remember these things. Second thing, sine square of theta is equal to 1 minus cos of 2 theta divided by 2. Cos square theta 1 plus cos of 2 theta divided by 2. So this kind of a formula we have to use here for solving a numericals. Next thing you should remember, that is sine of pi by 2 plus theta, which is equal to, see, 90 plus. 90 plus. You should remember these things. When I'm taking that as 90 plus theta, it will become cos of theta. But the sign will be in second quadrant. If you remember, in first quadrant, all the trigonometric ratios are positive. In second quadrant, only sine and its opposite. Sine opposite is what? Not cos. Sine and cosec are positive. Rest all the terms are negative. In third quadrant, tan and cot are positive. Rest all the trigonometric ratios are negative. And in fourth quadrant, that is the 360 part or fourth quadrant, cos and its opposite, we can say that sec is positive. Rest all the terms are negative. So this is pi by 2 plus theta means 90 plus something means it will lies in the second quadrant. It will lies in the second quadrant. So you can just see that. Suppose this is my first quadrant, this is second, this is third, this is fourth. So this is all trigonometric ratios are positive. This is sine and cosec. This is tan and cot. This is cos and sec only positive. Rest all the terms are negative. This is 90 degree. When I'm taking the 90 plus something, the trigonometric ratio will be changed sine to cos and with negative sign. Please remember this thing. When I perform this part, cos of pi by 2 plus theta, the cos will become sine theta with positive sign, because this in second quadrant sine pi by 2 something, you should remember this thing, sine pi by 2 sorry cos pi by 2 something means it will lies in the second quadrant. Pi by 2 मतलब इतना ही उसका कैपेसिटी हो गया. Pi by 2 something means it will lies in the second quadrant, because this is totally 180 degree. This is 270 and this is 360. So you should remember these things. Similarly, sine of pi plus theta, which is equal to minus sine of theta. When pi is there, the trigonometric ratio kept as it is. Similarly, cos of pi plus theta, which is equal to minus cos of theta. Why minus? Because pi plus means it lies in the third quadrant, and in third quadrant tan and cot are positive, rest all the terms are negative. So you should remember these things, this concept. When I say pi minus theta, if I'm applying that is pi minus theta means the trigonometric ratio will lies in the second quadrant only. This means sine will be positive, but when cos pi minus theta will be there, it will becomes minus cos theta. So you should remember these things clearly. This trigonometric ratios or trigonometric identities we have to utilize here. The next things we have to see here, sine of 2 pi n, which is equal to 0. Cos of 2 pi n, which is equal to 1. Cos of 2 pi n, which is equal to 1. So you should remember these things. This means what? Whenever cos having even number of pi, even means what? 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14 pi, 16 pi, any number of even number of pi. Means they have the value 1 only, positive 1. When sine of 2 pi n, it will by default 0. Similarly, similarly sine of n pi, that is equal to 0. Cos of n pi which is equal to plus minus 1 raised to, sometime writing is minus 1 raised to n. Means depend upon the value of n. If n is even, we will get positive value, as I told. When even of pi in cos is always 1. When n is odd, we will getting minus 1. That's simple. You can see you by using calculate, you can calculate. You can substitute the value of cos pi and you can observe that is it will becomes minus 1. While substituting cos of 4 pi or cos of 6 pi, cos of 8 pi, you will get plus 1. Cos of 3 pi, cos 5 pi, cos 7 pi, cos 9 pi, cos 11 pi, any odd number, you will get by default minus 1. So these are the some standard terms or standard which we have to suppose used in this upcoming chapter or upcoming module. Fourier series, very simple module, but totally depend on totally depend on integration by parts. If you remember and if you understand this term or this concept of integration by parts, definitely you are going to tackle this problem. If you are not going to concept, definitely it is a very big deal module, or we have to do little bit more on this Fourier series. So this is just a basic revision of Fourier series. Now going to define what is Fourier series. When I say Fourier series, basically this is again a transformation of a time domain function to frequency domain function for a periodic functions. Definitely, when you will enter in a seventh or eighth sum, you will have a subject of discrete DSP, discrete signal processing subject is there. That time you will understood what exactly we have to perform in a Laplace transform. Or might be in second year or third year, there is again one more subject in that you have to use a Fourier transform or something. But Fourier series is basically, it is a continuity series, continuous series. Whenever we have to define any kind of a transformation or any kind of a signal, when the word is signal is coming, signal, then we have to utilize the Fourier series because the signal is continuity or discontinue. So Fourier series is based on the signal concept or signal processing. So whenever there is a signal, whether the signal is we can say the frequency based signal, or when the signal is time based signals, the Fourier series always works. So we have to solve here Fourier series. What is exactly a Fourier series? So I'm writing here that is definition f of x is equal to a0 plus summation of n equal to 1 to infinity, or sometimes it is written as a 0 to infinity, an cos of an cos of nx pi by L plus summation of n equal to 1 to infinity bn sine of n pi x by L, or nx pi or n pi x. It's the multiplication things, so we can do anything. This is basically Fourier series where a0 is equal to 1 by 2L integral c to c plus 2L f of x into dx. an is equal to 1 by L C2 C plus 2L f of x into cos of n pi x by L into dx, and Bn is equal to 1 by L C2 C plus 2L f of x into sine of n pi x by L into dx. So this formula is known as a Fourier series. यही पूरा पूरा formula है आपके लिए. You should remember these things very well and kept it next lecture during the solving of this numerical. This is a Fourier series. Fx is equal to a0 plus summation of n equal to 1 to infinity an cos n x pi or n pi x by l, or summation of n equal to infinity bn sin n pi x by l. A0 an bn is separately we have to integrate and we have to solve so that we will get the results. During the next lecture, when I'm going to take tomorrow, that time I'm going to solve the problem based on or type wise we can solve. If anyone having any doubts regarding this, whatever I explained today, you can just ask, or if no doubts, I will take the attendance and will take the.
सर थोड़ा नीचे करो ना, नोट डाउन करना है.
You may leave now. I taken the attendance.